Okay, so now that we have a process, what we're going to do now is basically use that process to solve it, and then what I'm going to also do is use my technology. I'm going to use my Desmos calculator. You can use your TI calculator to basically test that our theory is right. So what we have here is I've got a polynomial, a quadratic actually, greater than 0. When is it greater than or equal to 0? So essentially, right, we're trying to figure out where are we crossing the x-axis, right? So we have a parabola. It is opening up. So we're trying to find out where do we cross the x-axis and where are we above the x-axis is essentially what we're trying to figure out here. We'll actually take a quick look at this in 4.5 and figure out another way we can solve this. But right now, in 5.6, we're going to use my process. So it starts off, right, step 1 is to figure out when am I actually equal, right? When am I equal to 0? And when am I undefined? Well, there's no undefinitions here, so we don't have to worry about that. And then solving this, I believe if we factor, let's see, I think a 3 and a 2 and a minus and a plus. So let me check that, right? So we get x equals negative 3 halves as a value, and x equals 2 is a value. Let me double check that real quick. Yeah, and so that's step 1. Right? Step 1 is to find out where we equal, right? And there's no undefinitions, right? So we don't have to worry about that. So step 2, what I now need to do is put these on a number line, right? So somewhere over here is negative 3 halves, and somewhere over here is 2, and somewhere in between is 0. And you can see what I have, right, is I've got an interval to the left of negative 3 halves, I've got an interval between negative 3 halves and 2, and I've got an interval to the right of 2. So I have to figure out, right, we already know graphically, if we were to graph this function, we are crossing the x-axis at those 2 locations. As a matter of fact, equals 2 is allowed, so I'm going to color them in with a closed dot. So we basically have to figure out, is the graph over here above or below the x-axis, above or below, or above or below? And that's where we do step 3, right? Step 3 is we start testing intervals. And what I always try to tell my students is you don't necessarily need to know the actual answer. We just need to know the sign. Are we positive or negative? And so really the best place, rather than plugging values into the function itself, we can actually plug it into the factored form. It's a little easier to see if we're positive or negative. So what's to the left of negative 3 halves? Well, there's a lot of possibilities. How about I choose x equals to, let's say, negative 3, right? And so when I plug it into here, right, let me go ahead and just plug it in, and then as we slowly get out this, I think you guys will start seeing, right? So this is a negative 6 plus 3. The net effect is this is negative, right? If you wanted, it's negative 2. And then over here we get negative 5. So we actually can find the value, but a negative times a negative is a positive, and so we are positive there. And so since so on this part of this axis, we are positive. In this interval here, x equals 0 is available. And rather than plugging it in, right, I'm just going to kind of take note of the values. 2 times 0 plus 3 is a positive 3, if you will. And 0 minus 2 is a negative 2. A positive times a negative, well, we have a negative 6. So we're negative on that part of the axis. And then last but not least, something that's bigger than 2, well, why don't we try 3? And then rather than trying values, I'm looking for signs. So 2 times 3 is a 6, plus 3, that's a positive 9, if you would. And then 3 minus 2 is a positive 1. We actually get 9, but what's more important is that we're positive on that interval. So now we're ready to do step 4, right? What part of the intervals make this true? Well, we have to be greater than 0 or equal to 0. So we're going to color in this part of our axis. We're going to color this part of our axis. And then we're going to use dots at negative 3 halves and 2. And so step 5 is to write our answer now in interval notation. And I've got the intervals right here in front of my face. So this interval is negative infinity to negative 3 halves. We include 3 halves, right? Union from 2 to infinity, include 2, and we're open at infinity. That should be there. So when we go look at this graph then, when x is less than negative 3 halves, or when x is greater than or equal to 2, the graph is going to be above the x-axis. So there's negative 3 halves, and there's basically 2, and we can kind of get a feel for you can almost get a feel for the graph, right? We're above it, we cross, we're below it, we come back up. So kind of a payoff from all this analysis is you can actually graph the function because we know where we're above, we're below, and where we're crossing. So there's basically our answer. To verify this, I will go to my Desmos, right? And when I go to my Desmos and graph this function, please graph it. There we go. Right? So when we graph this function, we can pretty much see, right, that at 2 we're crossing the x-axis, and we know that to be negative 3 over 2, although that doesn't, yeah. So there's negative 3 over 2, and we see that we are in fact, right, if we're to the left of negative 3 over 2, we're positive. When we're to the left of positive 2, we're positive, and then when we're between negative 3 halves and 2, the graph is below, and which is what we don't want, and which our analysis is showing. So from this part we're positive, from this part we're negative, from this part we're positive, and we're trying to solve that type of inequality. So there's our game plan basically at work. All right, I think I have time for one more. So let's go ahead and we'll do that. So again, for the next one, to solve this inequality, less than or equal to 0, we want to basically figure out when are we actually equal to 0. Since it's already factored, that's kind of nice. We can see that 1's a value and negative 2's a value, and we're actually not undefined because there's no division by 0. So our next step then is to take those values, negative 2's on our axis, 1's are on our axis, and 0 somewhere in between. And since we're solving a less than or equal to, I know that I can use the closed dot at negative 2 and 1 because they satisfy the equality. And so now we're ready to go do step 3, right, which is to figure out, well, what's my function doing? Is it a positive or negative? Is it positive or negative? Is it positive or negative? And this is where you start testing values. Again, we really don't need to know the value, we need to know the sign. So watch what I do here. So something that's to the left of negative 2, again, is negative 3. If I plug negative 3 in here, I get a negative 3 minus 3, which is a negative 4. But when I square it, this is ultimately positive. When I have a negative 3 plus 2, right, it's a negative 1, so that's ultimately negative. Negative 1 as a matter of fact. Well, positive times a negative is a negative, so I just verified that I'm negative on that route. Again, I'm trying to speed things up because, you know, you guys do have some time test. So rather than trying to find the exact value, all I'm interested in is the sign. Where am I less than 0? Where am I greater than 0? So just worry about the sign. When I put a 0 in here, right, 0 minus 1 is negative 1. When I square it, I get a positive value. 0 plus 2 is 2. It's a positive value. A positive times a positive is a positive, so I know I'm positive on that segment of the x-axis. And then last but not least, right, x is equal to 2. Well, 2 take away 1 is 1. Squaring it, we get a positive 1. It's positive. 2 plus 2 is a 4, right? And so we know it's positive. And if you wanted to find the exact values, knock yourself out. But I know a positive times a positive is a positive, so we're positive there. All right, and so now we're ready to do step 4, right? Where, you know, what am I going to shade? Well, we want things that are less than or equal to 0. So I'm going to shade that, and shade that region there. So we have kind of a very odd solution here, right? We have an interval here, right? So that's negative infinity up to negative 2, and we're including that. But there's no interval here. There's just a particular value. Oops, and that value is 1. Let me write that real nice. So that's how I'd actually write that value. So this is a discrete set. There's only one value in that set, but that's an interval. So we're kind of combining interval notation with discrete notation, and that's how we basically do that. All right, I've got one more to do. Hopefully you're kind of seeing that pattern again. Step 1 is to solve the equality and make sure we find all the undefinitions. Step 2 is to put that on a number line. Step 3 is to start testing values in the, again, use the factored form. You can find the exact values or just do a sign thing like I did here. We're talking about signs. And then step 5 is figure out which parts of the x-axis that we've analyzed satisfy the given inequality, which allows us to write our answer in interval notation or even discrete notation if allowed. Right? So I've got one more to do for this thing. So, but I'm already 10 minutes into this, so let me go ahead and cut away, and I'll come back nice and fresh to do that next video.